Hello there, squad mates. Here we are again for another Smart Science discussion.
Are you ready, guys, for another crazy science experiment?
What is happening when a liquid boils? Why do different liquids boil at different temperature?
To answer these questions, we have to learn intermolecular forces. These are the electrostatic interactions between molecules. So atoms within a molecule make a covalent and ionic bonds with each other.
But molecules also participate in interactions with other molecules. Let's look at the different types. First, we have an ion-ion interaction. Larger ionic solids are held together with this network of ionic bonds, which are the strongest intermolecular force because they involve formal charges.
After that, we have ion-dipole interaction. We first understand what a dipole is. The covalent bond in the water molecules are polar because oxygen is more electronegative than hydrogen and will pull the electron in the bond toward itself. Because of the bent shape of the molecule, when we combine those vectors, we see water has an overall dipole or a side of the molecule with some electronic access and side with electron deficiency.
Next, we have a dipole-dipole interactions. As you can guess, this is when dipoles interact with each other. As with pure water, when in liquid form, water molecules will move in such a way so as to always be making electrostatic interactions between the negative end of one dipole and the positive end of another dipole. Dipole-dipole interactions qualify for a special type. Hydrogen bonds, this is when dipoles generated by NH, OH, or FH bonds interact with each other.
These are just especially strong dipole-dipole interactions. They are especially strong because these are the most electronegative elements. So they will create the most strongly polarized bonds, resulting in a very strong dipole and therefore very strong dipole-dipole interactions. We can almost think of partial charges as some fraction of a formal charge. So the greater the partial charge, the stronger the interaction, though never quite as strong as interaction between formally charged particles.
Lastly, we have the van der Waals or the London distillation force. These names refer to the same force and are completely interchangeable, so I will arbitrarily refer to them as van der Waals forces. This is the consolation prize of the intermolecular forces because any substance can do it. Only ions make ion-ion interactions and only covalent molecules with a dipole can make dipole-dipole interactions. But absolutely anything can do van der Waals.
Now it's time for laboratory activity. These are the things to use for our simple and easy experiment. First, distilled water dropper. It could be medicine dropper or syringe, ethyl alcohol, 25 centavos or new 1 peso coin, acetone timer, and hydrogen peroxide. Ethyl alcohol has 22 drops and it evaporates in 37 minutes and 7 seconds.
Distilled water, 24 drops, it evaporates in 57 minutes and 9 seconds. Hydrogen peroxide, 13 drops.
Hydrogen peroxide evaporates slowly because it decomposes spontaneously into water and oxygen gas.
Acetone has 20 drops. It evaporates in 6 minutes and 57 seconds. Acetone evaporates the fastest because its intermolecular interactions are the smallest, allowing it to evaporate swiftly.